In the year 1799, Alessandro Volta, an Italian physicist, invented the first modern battery. A battery is a device that converts chemical potential energy into electrical energy. There are many variations of this, such as this very simple one made out of common household items. Three essential parts of a battery are the cathode, the anode, and the electrolyte. An electrolyte is a chemical compound that separates into negatively and positively charged ions when dissolved in a polar solvent. With it being sandwiched between or otherwise in contact with electrodes, the ions are what allows the chemical reactions between them to take place, and the current to flow through. The anode is the terminal of the battery that goes through an oxidation reaction and loses electrons, whereas the cathode goes through a reduction reaction and gains those electrons. When the two terminals are connected, the electrons lost from the anode flow through the circuit and into the cathode, powering whatever is between them along the way. In this specific example, the cathode is the copper, and the anode is the aluminum. The electrode is the salt and the vinegar solution that the cardboard is soaked in. Each stack of the electrodes and the electrolyte in the battery is known as a cell. This one has 7 cells. In Volta's original battery, he used copper and zinc for the electrodes, with pieces of cloth soaked in salt water between them serving as the electrolyte. It was the first electrochemical battery to produce a stable current, and to not lose much charge when not in use.
Pennies and foil and salt and vinegar is fun and all, but my favorite part of this is the reason why Volta went ahead and invented the first battery in the first place. Earlier in the 18th century, experimenting with static electricity was pretty popular. As the oft-repeated and possibly apocryphal story goes, another famous Italian physicist of the late 1700s, Luigi Galvani, was doing something with static electricity when he accidentally touched an electrically charged scalpel to an exposed nerve on a frog's leg. The leg twitched at the contact. This observation led Galvani to perform more experiments, such as connecting a long wire to the nerve in a frog's leg and holding it in the air during a thunderstorm, so that the recently discovered atmospheric electricity would make it twitch. When he did an experiment where he touched one metal to a nerve and another to the muscle, and again the leg twitched, he proposed his theory of animal electricity. Galvani believed that there was an intrinsic electrical force in animals that was responsible for muscle contractions and thus movement. When Volta heard of Galvani's experiment and explanation, he disagreed. Volta didn't believe in animal electricity. Instead, he proposed that the cause of the twitch lay in the two different metals that had touched the leg. The leg was serving as the electrolyte, although he wouldn't have said it in those terms. Instead, he proposed his competing theory of contact tension, that in essence says that two dissimilar metals with some sort of wet stuff in between was responsible for the current that caused the twitching. And what did he do to try and prove his theory? He invented the battery. Unfortunately, Luigi Galvani died the year prior to the invention of the voltaic pile, but the legacy of animal electricity and galvanism carried on. In 1803, Galvani's nephew, Giovanni Aldini, gained notoriety for demonstrating galvanism at the Royal College of Surgeons in London. In front of an audience of doctors and not doctors who were just there for the fun of it, he electrocuted the corpse of George Forster, a murderer who had been hanged earlier in the day. Witnesses reported that as Aldini applied metal rods connected to a large battery to the various parts of the corpse, the eyes would open and the face would twitch, and at one point his fist clenched and raised in the air. It almost appeared as if he were coming back to life. Ultimately, although neither Galvani's animal electricity nor Volta's contact tension and ideas about the nature of electricity were entirely correct, they were still very important.
Animal electricity was closer to reality than the earlier theories that proposed animals moved via the inflation of tubes of air or fluid in muscles. Galvani and Aldini were also vital to the use of electricity in medicine and the fields of electrophysiology and neuroscience. Galvanism was also cited by Mary Shelley as part of her inspiration for writing Frankenstein. As for Alessandro Volta, although many of his ideas are now known to be incorrect, the voltaic pile was essential in proving them incorrect, mainly through the work of Michael Faraday. Volta is considered a pioneer of the field of electrochemistry, and the unit for electric potential is named after him.
And then it'll taste different than when you just have one wire. And that's the electricity. Yeah? Tastes like a battery?
Yeah.
Okay.
And then